let's discuss about what are the steps in XgBoost. Okay, so let me tell you that as this is also a gradient boosting algorithm, so the initial steps for the XgBoost is same as the gradient boosting algorithm. Okay, it is same. At the first step, we have to make the initial prediction. Okay, this initial prediction is our first guess. Okay, this is the initial leaf. Okay, uh, um, so this can be anything regardless using whether you are using classification or regression. You can do anything. Okay, in regression you will take the average of the values, and classification similarly you can take the log of odds as we have discussed earlier also. Okay, after this what it does, similar way in gradient boosting, it tries to calculate the residuals and subtract those residuals try to gain the residuals by how it will compute the residuals by subtracting the predicted value from the observed value. Okay, these initial steps are the same. Then in the step 2, what you will be doing is once you have calculated the residuals, you will be making a tree based on these features and residuals. Okay, so always one thing you have to remember, that in XGBoost, whenever you are constructing a decision tree, it should always be a binary classifier. By binary classifier, what I mean is that it should always have two leaf nodes only. Okay, the levels can be any. Okay, you can take any level. Okay, but the leaf nodes, they should only be two leaf nodes. Okay, this what I mean by binary classifier. Now here comes the magic of the XGBoost. Okay, now the previous steps was same like gradient boosting, what we had done there, making initial prediction, computing residuals, fitting those to the decision trees. Now what XGBoost does, it will calculate, when you have built a tree, it will calculate the similarity weight for each of the leaves and the root nodes. Okay, how it will calculate it, both for classification and regression problems, you have different formulas for calculating the similarity weight. Okay, for classification, you have summation of residual square upon summation of probability into 1 minus probability plus this lambda. Okay, for regression, you have summation of residuals upon number of residual plus lambda. Okay, this lambda, it can be set with the help of hyperparameter tuning again. Okay, it calculates the similarity weight. Okay, so why XGBoost calculate the similarity weight? Okay, so let me tell you that XGBoost calculate the similarity weight in order to decide whether the feature, okay, as we have number of features with us. Okay, so it will decide that yes, this feature is the best feature among all, this is the best to split. Okay, this feature is the best record to split. Okay, so it will be deciding whether the feature it is taking as the root node is the best record to split or not. Okay, that's why it's calculating the similarity weight, and that's why XGBoost uh, is better than gradient boost. Okay, now after calculating the similarity weight, okay, what it does, it calculates the gain. Okay, how it's calculate the gain, it takes the similarity weight of the right leaf and add it with the similarity weight of the left leaf and subtract the similarity weight of root from the addition of these both leaves. Okay, you can see the formula. Okay, here uh, it will select the tree with the maximum gain and it splits from that record only. Okay, this is how it calculates the gain. Okay, whichever record is giving the maximum gain, it go with that record. Okay, so after selecting the best split, XGBoost will go for the next feature. Okay, similarly, okay, as it has chosen the first feature, let's say if it has chosen the first feature for the root node, now it might choose the third feature or the fourth feature for the next split. Okay, like this way, XGBoost will go for the next feature, and it repeat the same process of calculating the similarity weight, and then the gain of the tree, and selecting the tree with the maximum gain. Okay, this process goes on and on, and at last, okay, first let me tell you that it will select different features each time. Okay, and at last the addition of similarly we have done in gradient boosting, similar way the addition of all the trees are put together in order to get the final output. Okay, so I think these all things are clear to you all. This is the mathematics behind the XgBoost. Okay, it is same like gradient boost, just with a little difference of calculating the similarity weight and the gain and selecting the best feature for the split. Okay, that's why it's more good than gradient boosting. Okay, we have one more concept